This video, I will solve some Bayesian questions using the tables here. So using the tables are much easier sometimes. Okay, so I want to do a warning here. This method does not work in all questions. It works if a consistent table can be formed using the information given in the question. So this is important. So if you can apply it, yes, you can, but in some questions, some information is not given to make a clear table. So for this, in these questions, you can apply it. Otherwise, with the given information, allows you to do, to make all the table clearly, then you can use it. Now let's look at this question. A store sells TVs only from two companies. That's 40% from company A and 60% from company A2. And 5% of TVs from company A1 have a defect, and just 3% from company A2. So defects of 3% of the TVs from company A have defect. If a customer buys a defective TV, what's the probability that it comes from a company A1? So let's try to put them on a table. Now we have two companies. Let's say this is A1, company A1, company A2. And the other thing is the TV, some of the TVs are they have defective or they have defect. Okay. And some of them, they have no defect. So it means like problem. And everything is given in terms of percentage. So for this reason, there is no no number given, like the number of TVs or number of defective TVs, but just the percentages. In this case, we can use a table, and we can start from the population of TVs. So what's the total of the TVs? You can assume it's 100. Okay, assume the number of all TVs in the store. Okay, in the store is 100. Now let's use, okay, we will try to fill out the table by using this 100 here. Now the first information, 40% all of the TVs are from A1. So it means if the total is 100, then you can say it's 100 times, so 100 times 40%, so 40 TVs from A1. So you can say here 40. And since there's no other company, because it says only from two companies, so this will be automatically 60. Now let's try to fill out the other boxes if possible. Sometimes it's not possible, but I will show you. Now 5% of TVs from company A have defects, so it means 5% of A1 TVs are defective or have defective, let's say. So what is the number of A1? The number of A1 TVs, it's 40. So we have to find the 5% of A1 TVs, because the number of defective A1s now, the number of defective A1s, A1 TVs, it will be 40 times 5%, because we already have this one. So that when you calculate this one, you will get 2. So you say defective in A1, defective in A1 TVs is 2. So in this case, no defective will be, okay, A1 and no defective, it's 38 because we have the total here 40. Now, let's do the same thing for A2. So here, the information says that 3% from the company A2, the 3% of A2 TVs are defective. So we will do the same thing, A2, so it's 3% of A2 TVs are defective. So number of A2 TVs, it's now 60. So it's 60, and the number of A2 TVs, defective AT TVs, just 3% of 60. That will be 3% of 60, which is 1.8. Now, when you look at it, you will get 1.8, the number of A2 defective. Now, the rest is 1.8, it's 60, so the total is 60, so it has to be here 58.2. Now, in the same way, we can say the total of the defective now, the total is 3.8 here, and not defective is 96.2. They will add to 100. Now, this is the total of A2s and A1s. Anyway, now we have this table and everything now okay. Now, let's answer the question here. The question is, okay, now let's look at here. So the question is, if a customer buys a defective TV, so it's asking if it's a defective, so this is a conditional probability. What's the probability that it comes from A1? So here you have to, okay, we have to apply the multiplication rule for the conditional probability, or the conditional probability rule. This is BA1 and defective divided by the probability of defective. Now let's try to answer these from the table. So BA1 and defective, so what's the probability is A1 and defective? A1 and defective is 2 over, okay, 100 divided by defective, the probability of being defective. What's the total defective? This is 3.8. It will be 3.8 divided by 100. So this will be equal to approximately 52.0.52.52, 520, yeah, 53. Okay, we'll see. 0.53 if you round it. Now let's look at this problem. The study has shown that 7% of the persons living in a city suffer from lung cancer. Okay. Of those having lung cancer, 90% are smokers, and of those not having lung cancer, 25.3 are smokers. If a smoker is selected randomly, what is the probability that he has lung cancer? Now it seems there are two types of people, or like two. We have to do the table according to two things. One, suffering from lung cancer or not. Okay, so I will say the lung cancer here, lung cancer LC, the guys with lung cancer, and the guys without lung cancer. So I will say no LC. And there are smokers here, and there are non-smokers. And here, all data, I mean, everything is given in, all the number values are given, all are in percentages. In this case, we can try to do the table with 100. I mean, we assume it's 100. We can start by assuming the total is 100. So you can start here, total is 100. The total number of the people in the city. Now, okay, total, let's write this is total here. So we assume this one first. They assume that all people in the town or city is 100. Now, 7% of the people living in a city suffer from lung cancer. So it means, so this is the city population is 100. Now it says 7% of city people have lung cancer. So what does this mean? If city is 100 people, okay, it's 100 people only, we assumed it. And then from here you can say the people with lung cancer, so I will just say LC is equal to 7 over 100 times 100 people. So because the city is 100, so just 7. So in this case, the total number of the lung cancer guys is 7, and then number of LC is now 93. So 93 people have no lung cancer because they have to add to 100. Now, let's use another information here. The other information is this one. Uh, 90 of those having lung cancer, 90% are smokers. So it's saying like 90% of lung cancer is equal to the smokers and not equal to what I will say 90% of LC are smokers. Okay. Now, what is LC? We know LC is 7. So we will get small LC, smoker LC, smoker and LC can be found by this then, 90% of LC. So if we do this calculation, we will end up with 6.3. Now, the number of LC and smoker is 6.3. Now, here we have a decimal number, but it's okay because we assumed city is 100. For sure, it will be 100,000 people. So this 6.3 in reality, it will be 6,300 maybe. So for now, I mean, with our assumption, these numbers are okay. Even they're decimal, there's no problem. Now, now by using this, we can say here is lung cancer and smoker, and lung cancer and non-smoker is 0.7 now because when you add them, you get 7. Now, because of this. Now we will do the other one. Of those not having lung cancer, 25.3 are smokers. So it says 25.3% of no LC is or are smokers. So it means the number of, now what does this mean? Number of smokers and LC, no LC. So I'm saying this, someone is, the number of the guys who smoke and they have no lung cancer is equal to 25.3 over 100 times the number of LC. Sorry, the no LC, the number of no LC. No LC is 93, so it will be then 85.3 over 100 times 93. And this will be equal to 23.509. And then we can do the rest now. The rest is easy. Um, we can fill out the table because we know the totals. And here, 93 minus this value will give you, okay, the total will be 93 with this, so it will be 69.471. Now it's asking what? Now we know the total, so we can add this total here. The total number of total smokers will be 6.3 plus 23.529, which is equal to 29.829. And then when you subtract this one from 100, it will be 70 plus 171. Now we have the table and we can answer the question. A smoker selected randomly, what is the probability that he has lung cancer? So what is the probability if a smoker is selected? We know that this guy is a smoker, given that he has lung cancer. So what is this? This is the probability LC and smoker divided by the probability of smoker. So what is this? LC and smoker is what? LC and smoker is 6.3 over 100. It's because we're talking about probability. And we divide by 100. And the probability of the smoker is what? This probability of smoker is total is 29.829 over 100. So if you do this one, do this calculation, I mean, these cancel out here. These cancel out. And then we can get the answer as 0.21. Yeah, it's approximately 0.21. Now a group consisting of equal number of men and women. Okay, this is important. Okay, there is a group consisting of, it consists of men and women, equal number. Of this group, 20% of men and 50% of women are employed. If a person is selected randomly, let's find the following probabilities. Now, the probability of this person is employed. If this person is employed, what's the probability that he is male? Okay. Now, we have two things here. We have two classifications like men and women. Now, we can say here men and women. Okay, and here this group has 20% of men. Men and women, it's okay. And there's the other thing, the employed. So there will be employed and non-employed people. Okay, one warning is these things should be exhaustive. It means like all the population should be either man or woman or employed and non-employed. If there's another option here and nothing is given, so this table might not work. Okay, this is a warning. You will see it in the other question anyway, in the coming question. Now, let's do the same thing. And here everything is given in terms of percentages, so we don't have any number, because if you have a number, concrete number of the number of men or women is given to you, you have to put this in the table. You have to do this. You don't do an assumption here, because I'm doing an assumption here because everything is given in percentages. So I'm assuming the total number is 100. Now, men and women, it has equal number of men and women, so the totals should be 50-50 then, right? because of this fact. Now, of this group, 20% of men are employed. So it says 20% of men are employed. So it says 20% of men are employed. It will be 20 or 100 times 100. So sorry, not 100. Okay, be careful. Let's be careful because the men here is 50, so it has to be 50. If you do this calculation, you will end up with 10. So it means the men and employed, it's 10 here. So we can say men non-employed, it's 40. Now, and 50% of women are employed. So it means 50% of women are employed. So 50% of women employed. How many percent? How many women are there? I mean, number of women is 50, and then 50% of them, like 50 times 50%, it will be 25. So it's woman and employed is 25. So you write here 25, and here this has to be 25, then this has to be 35, and this has to be 65. And now everything is clear in the table, and when you add them, you get all 100. Everything looks fine. So here to check, you can check this one plus this one, it's 100, it's okay. This one plus this one, it's 100, it's okay. Now, now we can answer the questions. What's the probability that a person is employed? So how do you check a person is employed or not? You check, okay, this one, the number of employed divided by the total. The total is, okay, 35 over 100. Now, what if the person is employed? What's the probability that he is male? So it's asking what? It's asking among the employed, okay, the employed people. So it says like if the person is employed, what is the probability that he is female? I mean male. So we want this man here, okay. Now, what does this mean? This is a conditional probability. This is, we will check what's the probability that the person is man and employed divided by employed. Now, men and employed, well, let's check men and employed. Men and employed is now 10. Okay, 10 over 100. 100 is here. And then probability of employed is 30% over 100 and 35%. Okay, 35 over 100. So then it becomes 10 over 35. So you can say here, this one is 10 over 35. Now, if the person is employed, what is the probability of the female? Now, you know, it will be just employed given, okay, what's the probability that female given employed? So we will do it for women here. We will write the same thing for women. And here we will write employed, yes. And then we'll do the calculation again for each of them. Now let's see. Women and employed, it's 25 over 100. And then employed again, 35. It has to be 35 over 25 over 35. And if you do some simplification, I think this will be equal to 5 over, okay, 35, sorry, 25 over, I will write, okay, to see something, okay, I'm writing this one as 25 over 35, which is equal to 5 over 7. But as you see here, they complete each other because employed, male, female. So when you add them, you have to get what's the probability that um, the person is employed and he is male or female. So it has to be 1. Okay. So when you add them, it's equal to 1. Now let's look at the last example.